Our biomechanics project is about the initial jump and water entry of swimmers. The main objective is to analyze the initial jump, which embodies a great variety of movements and techniques, and this creates a need to analyze both the upper and lower body. In this study, the performance of four swimmers from the representative group, two male and two female, will be analyzed in order to provide feedback to the coach on their performance. These will be the variables that will be analyzed in the study. Leg angles and water entry are fundamental in this study since these dictate the level of performance.
As it can be seen, an optimal angle can allow the swimmer to increase their potential flight distance, thereby increasing their performance. If the takeoff angle is too high, the angle of entry will be steep, leading to a deep gliding pattern requiring more time to return to the surface. If the swimmer takeoff angle is too low, then the entry will be flat, resulting in increased drag when entering the water, increasing the wave drag component.
The water entry consists of four main stages. The first stage is the starting block, and in this case the swimmers are using the running start position. In this position, one foot is placed at the front of the block and the other foot is placed to the rear of the block. The hands are placed on the front edge of the starting blocks. The back knee is flexed at close to 70 degrees, while the front knee is flexed to 130 degrees. They should always have the head down and the hips as high as close to the edge of the blocks as possible. This positions the center of gravity closer to the edge of the block. The next stage is the initial push. In this stage, the arms are driven forcefully forward and upward from the blocks, which will increase the downward-backward forces on the feet and the resulting propulsive force. Arm swing is complete as feet are leaving the blocks. As back legs leave the block, the legs should be extended forcefully upward from the blocks. This forceful hip extension will increase the upward forces on the front foot and increase the velocity of takeoff. Leg action has to occur before the front leg leaves the block. The third stage is the dive. The swimmer should travel the optimal distance through the air before entering the water. This skill requires a forceful push-off by the legs on the block and an optimal entry position. Finally, we have the water entry. In this stage, the arms, head, and body are aligned during entry. The shoulders are pointing directly upwards in a position of 180 degrees of shoulder flexion. The swimmer must keep the head down and arms down while following the whole body through the water. As the upper body enters the water, the hips continue to extend to align the legs with the trunk. During entry, the body assumes a streamlined position to minimize splash. An ideal angle of entry should be around 30 degrees.
According to the variables previously selected, we decided to record using a camera at a 90-degree angle from the starting platform to have the best view possible. We analyzed the two trials of each swimmer using the tracker software to be able to have a feedback with the coach and the swimmers and record once more to see the improvements.
According to literature review from previous study about water entry, we expect these results. Angle of entry. The best angle to enter the water is around 30 degrees. Position of arms and head. The arms should be next to the head, fully stretched to create the lowest possible area that hits the water, while the legs should be stretched fully and in a 180-degree angle with the trunk. Jump height. The higher the subject jumps, the best initial starts thanks to force and strength of lower body. Flight distance. The distance should be as much as possible in order to have as much airtime as possible and travel the furthest distance. Flight time. The flight time should be as high as possible to assure the best start.
From the two trials recorded, here we are presenting the results of the best trial. In the case of our first subject, Priscilla, she had a back leg angle of around 74 degrees and a front leg angle of around 136 degrees. Her jump height was one of the most significant amongst all the swimmers, reaching a height of 0.125 meters with respect to the original position. Her flight distance was of 1.806 meters, and when leaving the platform, her legs were extended to increase upward force. The arms follow a coordinate path, and at entry, arms are completely stretched, head down, and splash is reduced. This gave a result of an angle of entry of 42.8 degrees.
In the starting block, the second subject had a back leg angle of 76.8 degrees and a front leg angle of 133.8 degrees. Her jump height was low, covering 3.6 centimeters. On the other hand, the flight distance covered was 1.74 meters. When the swimmer is about to enter the water, she tends to flex her hip, making it impossible to form a vertical line with her legs. This produces a greater water drag, giving as a result an angle of entry of 44.9 degrees.
The third subject of study, Cesar, had an initial back leg angle of around 84 degrees and a front leg angle of 141 degrees. The jump height of Cesar was insignificant, and the distance covered was of 1.817 meters. At entry, arms are completely stretched, head down, and the splash is reduced, causing an angle of entry of 40 degrees. However, there is no upward force, causing the swimmer to go directly under. Our final subject of study, Ricardo, had a back leg angle of around 75 degrees and a front leg angle of around 143 degrees. The jump height covered was of 0.097 meters, creating a flight distance of 1.97 meters. When leaving the platform, legs were extended to increase in upward force. The arms followed a coordinated path, and at entry, arms are completely stretched, causing an angle of 52 degrees. However, legs cause a splash when entering the water. After analyzing the first trials, we returned with the coach and the swimmers to give them feedback. We had a short meeting with each of the subjects of study and gave them tips about how to improve their technique. After that, we recorded each swimmer again for one last trial to see the improvements made.
Regarding our first subject, Priscilla, she had a very consistent technique since the beginning, so there were not great improvements to be made. However, with the adjustments of the legs made for the starting block, she reached a higher distance of almost 2 meters. The maximum height was also increased, and the entry angle stayed consistent and body position remained as efficient as in the first trials.
Moving on with Sylvia, there was a slightly bigger distance covered, 1.78 meters, as a result of an increase in leg angle. She had a front leg angle of 134.4 degrees and a back leg angle of 80.6 degrees. Maximum height was also increased to 5.5 centimeters. Entry angle stayed consistent and body position was improved in comparison to the first trial, which resulted in less splash.
The third subject, Cesar, had a bigger distance covered by 0.181 meters as a result of a better angle in the legs. The entry angle was also improved by 4.35 degrees, creating less water drag. Our last subject, Ricardo, had a bigger distance covered by 7.1 centimeters as a result of a better initial angle in the legs. The entry angle improved by around 5 degrees, and the biggest improvement was the legs were stretched in the entry, which resulted in less water friction and splash, creating a better technique.
After analysis, it has been clear that every swimmer has distinct ways of encountering a dive. However, it is evident that they can all be measured using a number of variables such as angle of entry, position of arms and head, flight distance, and flight time. All four swimmers show a considerable improvement in their dive compared with the first trial. The male and female swimmer with the best initial dive were Ricardo and Priscilla, respectively. Therefore, a correctly executed mechanical analysis of variables can represent an important difference at the moment of a competition. Even the most slight adjustments in technique can increase general performance and even prevent any kind of injury.
We would like to thank the coach Mauricio and the representative swimming team for this project and their time.